Welcome to another episode and video on my Arduino MegaADK for Android without Android and with electronics and some fischertechnik mechatronics. Last time I found after some rewiring that for some reason the mechatronics with the chain doesn't work anymore, and that's a bit strange. The rewiring is that this blue wire is now connected to the same output from the transistor as where this diode, safety diode, is connected, and it would be nice if the wiring indeed stays where it is, otherwise it won't run. That is better. But the point is, as I will shortly show you, that this probe from the oscilloscope, yellow color probe, shows a nice signal of pulse modulation on the oscilloscope. This one shows a slightly different one. Then this LED should burn because this transistor works. If this transistor wouldn't work, then I would have most likely no signal. But for some reason it just doesn't work, and it did not work last time, although at times it did. So why it doesn't work, I'm not quite sure. But there's more, of course. This motor is supposed to work when I press this button, and then when I press this button, this RC circuit, resistor, capacitor, and then with an LED that shortly blinks when I press this button. But after holding it, this LED and this motor should work shortly. Last time not so much. Then this lens lamp should activate this phototransistor. That mostly works. And then finally an NTC, which has gone to the background recently because of the other problems. So back here. Now the speed of pulse modulation depends on the periodic, and one period is of course the combination of positive pulse and negative pulse. And on the oscilloscope you can now see that this yellow pulse, which is directly from the board, shows long negative, short positive. That means that it most likely won't run the motor. So let me change this. Or I should be able to change. And this is strange, because I'm now turning this potmeter and it doesn't show any change, and that is very strange, because upon turning this potmeter it should change from long here to long there. This should get longer, and it doesn't. And this is the signal after the transistor, and that should change with it. So why doesn't this work? More importantly, why doesn't this work? So one more thing to find out. And I am looking at this wire, but this wire seems to be quite normal, although no, it is not completely normal, because upon touching the wire the signal changed. So now let's see. Yep, and now I can make a bit of difference. So that wire wasn't, the blue wire from the board was not entirely accurate. Anyway, now the question is still, why doesn't it work on this side? Because this has to run. Let's find out, or try to at least. Alright, so let's have a look at the schematics. The problem that we are dealing now with is this part of the schematics, this part of the circuit. Resistor to transistor, and then for safety a diode, and at the same point the motor. And this should work. Then also an LED to show that there is signal over it, but if you look closely, then you will see that here an LED with after it a resistor, here a diode, an LED actually, with a resistor after it. Same thing here, but not here. So I'm going to change that, and let's just copy this one. So this one is going to be reassigned here, coupled here, and there you go. Save, and then I see that I have two R13s. That is of course not recommended. So this will be then 14. And this will be 15. Alright. And this is all to keep things uniform. That said, let's implement it. So here is the LED, which I, by the way, in between tested. And it works. So I am going to take this one out for now. Put it in the other direction right here. As it should work. Then this resistor will go from, well, that doesn't matter where from. Most logical will be from here to ground. So, and this is not the most logical place, I think. But we'll see. Anyway, right now it doesn't matter how it is, because it doesn't show to work. But considering, let me change the camera angle a bit, camera point. So yellow probe is right here, the blue probe is right here, and the purple probe is right here. And Now I can of course measure if there is any signal to the LED. So let me start the fourth probe. And use it to measure any value right here, and that has a pulse modulated signal, which is in itself not a problem, but that proves that there is a signal there. Then and here is no signal. Well, there should be. So measuring right here, there is signal. And the strange thing is then that here suddenly or is there signal? There is, it is not a complete flat line. Yeah, when I measure this way, there is definitely signal. And I'm now measuring here. Well, that's obviously nothing because it's ground. But since there is signal on this side, the LED should work, but it is a very low voltage. If you look right here and I go to channel 2 and I change the voltage, so now one block is 1 voltage, then you see how low the signal actually is. So let me change it back to 5. So that gives an idea how it works, but the problem is as well that with other circuits it does work. So why won't it work here? And once again, taking this wire out of here and put it here, I did last time, and it just works. So somewhere is not entirely accurate. Alright, focus, or more appropriately, other focus, this circuit. And that means this one. And again, time for here. So this is one motor and this is the other. So when I press this one, AVR C circuit going here, and when this is getting a signal, then this motor should be started with this LED being shown upon, or activated is better. Last time we didn't, so let's have a look. So for the motor, which is here, I have two things to look at. First of all, port 3 that controls or sends the signal to the motor and this LED, and port 2 which actually loads the capacitor, and then with pressing the switch, port A5 gets a signal and actually says, alright, let the motor run. When I press the button, it works. The LED works. Holding the button, doesn't do anything. And when I look at the code, I did change it a bit, that is true. But not in such a way, because I'm now talking once again about this port with the motor, and maximum value, let's see, yep, 255 actually. So in 3, let's reduce this to 255. And then what? Out. Yeah. For how long? How long should I do that? What time? Well, let's delay this as an example for 1 second. See if that solves something. Oh, I forgot something, because I do have this one, and without changing ownership, once again, I can't do anything. So now I can do things. Then I still have to select a proper board, ADK, proper port as well. Oh, that is alright. So now I can upload. That's alright. But will it work? And purple line shows absolutely nothing. Third line from above, no sign of life, and that's not good. And I am measuring on bare metal, so that would be fine. Let me take this probe off and put it on something that is correct. For example, right here. Yeah, okay, so the probe works. That is no problem. And let me show you more appropriately here. I am measuring where I tried before. Gives a nice signal. So this means that the probe is alright, fortunately, but there is no signal on this wire, and that is not so nice. So how to test that? Well, there's only one way to test that, and that is to test right here, and there's nothing either. There is no signal on this pin, so it's not the wire either. Carefully touching it again. I should also be able to connect it here. Should not matter anyhow. But main thing is, why does it do anything? Is the port broken? Could be. I am inclined to change it back to digital and then see if it works. So let me just do that. Alright, this means digital. Going to port 3 right here. And saying okay, I won't cut it out entirely. You never know what happens. Oh, that is a good one. I should look at the analog output. So I haven't yet uploaded it, changed it, but I should take a look here. Output value 2. What does it do anyway? So let's do that. Yeah, oh, that's a good one. For now, let it be analog then. Alright, then monitor. And what do I need to see? Alright, let's scroll down a bit. Oh wait, I'm making a mistake. I am making a mistake. I need this one. I need these two. Not this one. Because this one is just another output to analog pin 3, while I need to see what is on it. And if this, and I'm interrupting myself continuously, I'm aware of that, but I need to see which one is giving the real value. So the only thing I need to do, not this one, I need out pin 3. So what I want is to see that analog out pin 3 actually does give the value that I want. So I don't need to set it here. I need to print it right here. Analog out pin 3 is and serial print line and then analog out pin 3. Now I will see if it really does do it. So let's go and watch it. And it has an if, so I need to press the button to see it. It's 3. Analog output pin is 3. Oh, that's not good. That's not good. Its value is way too low. Not 255. It should have been 255. So I'm going to change it to digital and then see if it is high. I realized that I may have made another value assigning mistake, but I have now changed everything to digital, and digital should now be either high or low. So let's see whatever it gives. Expected where? Oh, here, yeah, semicolon. We're talking C. Alright, so now, and of course the monitor. How can this be? This is to out pin 3. It should be high. This makes no sense at all. Absolutely no sense. What am I doing wrong? And how? This is alright. High. Yeah, I am doing things the same way. Writing out high, writing out low. So why is this being assigned 3? This is declaration. A constant integer for this. And it hasn't been any other way. Neither have these been. Output. Output. So mysteries are adding up right now. And that's not funny. In any way. If I write to digital out pin 3 the value high, then I should get high, not 3. So something is very odd here. And unfortunately, once again, time is running out and things are mostly unsolved. And I don't like that. And with a value of 3, oh, look at that. The LED just blinked, and I'm talking about that LED, this one. This is very, very strange. Okay, let me look back. I can't look back, unfortunately. Things to check out. Because this is not correct at all. If things are high, then value should be high or 1 or whatever, but not like this. And how many have I declared digital? Not many actually. Digital pin output 8 is being used where exactly? Right here. So what will I get as an output if I copy these right here? And then of course making this 8 and this 8. That's the last thing I'm going to check. If this gives 8, there's something else going on. So last time to check. Right. 8. This out is 8. Not high, but 8. Okay. I need to verify the board, because this is not correct and time is up for now, unfortunately. So that's it for a mysterious episode. First of all, why doesn't this work? Well, it does work on another board or other boards, the same construction, and it did work previously, but then if I put this here it works, but it should work here as well. I did not check this one, but it works. I did not check this one, but it works. And this one does not work, and that is a very big problem. So why am I getting the value of 8 when I am printing digital output, which should be either high or low, 1 or 0? Doesn't make sense. So my suspicion goes to the board. Thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up. Leave a comment, very much appreciated. You can also follow me on Twitter. Please retweet, like and leave a comment. You can also follow me on Instagram. Please like and leave a comment. If you like my videos, my channel, please show your support and make a small donation. You can also decide to become a patron and have your name mentioned as a supporter by a monthly pledge. And depending on the pledge you make, your name will be mentioned either just on my website or on my website and my videos. Thanks for watching, and bye bye.